Hi, welcome to the video lecture on software engineering, and today we are going to discuss about the various process models. So the topics to be covered are prescriptive process models, evolutionary process models, and unified process model. If you look into the concept of a process model is basically developed to bring order to the chaos of software development. So whenever you look into the concept of a process model, these models will definitely bring some kind of a structure to software engineering work, and they will also provide an effective roadmap for the teams to work on the project. So software engineering and products that are produced remain on the edge of chaos. So when I say the edge of chaos, it is nothing but a natural state between order and chaos, and it is always a compromise between structure and surprise. So if I talk of something called the edge of chaos, it is nothing but an unstable, partially structured state. So in order to bring absolute order, we are looking into the different process models. So each process model in this presentation will strike a balance between the need to impart order in a chaotic world and the need to be adaptable when things change constantly. So when things are going to be dynamic, how do process models bring in order, otherwise which would result in chaos? So the first one is called a prescriptive process model. So the prescriptive process model basically strives for structure and order in a software development. The activities and tasks basically occur in a sequential fashion, and in a prescriptive process model, the order and consistency are dominant issues that needs to be addressed. So as the term indicates, we call them prescriptive because they are almost like a prescription which a doctor normally issues when you visit a hospital. And prescription needs to be strictly followed, that is given by a doctor, otherwise you will have a problem with your health. Similarly, prescriptive will define a set of process elements that includes activities, actions, tasks, work products, QA, and so on, and that needs to be followed in letter and spirit. So each of the models will prescribe a specific process flow or a workflow, and this would basically describe how the different process elements are interrelated to one another. The first prescriptive model is called the most famous classical life cycle model or the waterfall model. And you could see a picture of a waterfall here. And the waterfall model could be visualized by looking at this picture where water in the waterfall falls linearly from the top to the bottom. Similarly, the waterfall model follows a strictly sequential and linear approach where it starts with A, moves to B, C, D, E, and so on, and A, B, C, D, E represents the different stages of the waterfall model. So this waterfall model could be applied only when the requirements of the problem are well understood. So work flows in a linear fashion, starting from communication through deployment. So for example, an adaptation to a billing software that is mandated because of introducing the GST could be developed using the waterfall model. Certain times you can also use the waterfall model for some kind of new development efforts, but the condition to use the waterfall model is requirements are well defined, requirements are reasonably stable, and requirements are all well understood, then you can use the waterfall model to develop your project. So this is the oldest paradigm for software engineering, and it starts with communication, goes through planning, modeling, construction, and deployment. So it basically starts with communication and culminates in deployment, where probably you get what is called the delivery, support, and feedback. So this V model, which is a slight variation of the representation of the waterfall model, depicts the relationship of QA to the actions associated with communication, modeling, and construction. So if you look at code generation, which is mapped to unit testing, component design is mapped to integration testing. Integration testing is also mapped to architectural design. Architectural design is mapped to system testing, where system testing is also mapped to requirements modeling. And requirements modeling basically is mapped to acceptance testing. So as the software team moves down the left side of the V, the basic requirements are refined into progressively more detailed and technical representations of the problem. Once the code is generated, the team moves up the right side of the V. It will perform a series of tests, that validate each of the models. So basically, there is no fundamental difference between the classical lifecycle model and the V model. So the V model basically provides a way of visualizing the verification and validation actions in software engineering. Otherwise, the V model and the classical lifecycle model are fundamentally the same. When you look at problems with the waterfall model, so real projects will rarely follow this kind of a sequential flow. Normally and practically speaking, it will be difficult for the customer to state all requirements explicitly right away in the beginning itself. The customer will definitely need patience, because you will see a working version of the software only late in the project time span. And this waterfall model has a bigger problem, which means it leads to what is called a blocking state. In the case of a waterfall model, there are certain team members that need to wait for other members to complete the dependent tasks. So the major problem here is the time waiting to complete basically will exceed the time that will you be basically spent on productive work. So these are some of the problems that are normally encountered in the waterfall model. So we look at a different prescriptive model that possibly overcomes the issues faced in the waterfall model. So this model, what we are going to discuss now, is called the incremental process model. So when can I use the incremental process model? Whenever the initial requirements are reasonably well defined, the overall scope of the development effort precludes a purely linear process. Then in addition, there might be a compelling need to provide a limited set of software functionality to users quickly. Then let the users use your software. Then you can go for refining and expanding on that functionality in the later releases. In such a cases, incremental process model best suits the project. So this is a diagrammatic representation of the incremental process model, where you probably see the project calendar time on the x-axis, the functionality and features of the software on the y-axis. Then you have delivery of the first increment, second increment, up to n, and so on. Irrespective of the process model, the GPF, the generic process framework, does not change, It starts with construction through planning to modeling to construction and deployment. So when you look at the incremental process model, this model is a combination of the linear and parallel process flows. The incremental model applies the linear sequence in a staggered fashion as calendar time progresses, and each linear sequence will produce a deliverable increment of the software. Some of the examples that could be probably would have been developed by using the incremental process model are, for instance, a most common application you are using on a day-to-day basis called MS Word. Let us say I develop the core product, which is basic file management, editing, and document production in the first increment. More sophisticated and editing, document production capabilities in the second increment. Spelling and grammar check in the third increment. Advanced page layout in the fourth increment, and so on. So you deliver the first increment, give it to the customer, let him use it. You get the feedback. In the meantime, you start working on the second, third, fourth increment, and so on. So that is what the incremental process model basically does. So what you deliver in the first increment is called the core product. The core product basically satisfies the basic requirements that need to be addressed. Delivered to the customer, he will do a detailed evaluation. In the meantime, you look at the plan for the next increment, and this process is repeated for each delivery of every increment until you could probably deliver the complete product. So in summary, you could say prescriptive models have been applied for many years in an effort to bring order and structure to software development. So when you look at sequential process models such as the Waterfall or the V model, they are basically the oldest software engineering paradigms, and incremental process models are iterative in nature, and they produce working versions of the software much faster compared to the waterfall model. Then the next one is called the evolutionary process model. So software, like other systems, are definitely complex, and they only evolve over a period of time. Also, business and product requirements are highly dynamic in nature. So a straight line path is totally unrealistic. Also, every software is basically driven by tight market deadlines, and it is not practically feasible to probably deliver the entire product in one single shot. So in all of these situations, it is better to accommodate the evolutionary process model in order to develop your product. So evolutionary process models are iterative in nature. There are two common evolutionary process models available. They are the prototyping and the spiral model. If you look into the prototyping model basically works well if a customer could define a set of general objectives for the software, but he is not able to give the detailed requirements of the functions. So in other cases, the developer might be unsure of the efficiency of the algorithm or the adaptability of the OS or the human-machine interaction, and so on. In all of these situations, it is recommended to use the prototyping paradigm. So this prototyping model can be used as a standalone process model, but it is well adapted when you could probably combine this prototyping model with a standard prescriptive model as well. So irrespective of how you apply the prototyping model, this model will basically assist the stakeholders to better understand the problem when requirements are fuzzy. So to put in simple terms, whenever requirements are fuzzy, this prototyping model is best suited. So this model basically again begins with communication. So where you meet stakeholders and define the overall objectives of the software. Then you have something called a prototyping iteration, where you have something called a quick plan and a quick design. So you have something called the quick design that basically focuses on the human interface layout or the output display formats and so on. Then once you have the quick design, that basically leads to the construction of a prototype. The prototype is basically divided into two categories. One is called the throwaway prototype. The second one is called an evolutionary prototype. In a throwaway prototype, once you probably develop the prototype, evaluate it, and get feedback, you discard the prototype. In the case of an evolutionary prototype, you develop the prototype, then you probably evaluate it, then you get feedback, and you do not probably discard it, you probably use it for further iterations, and that is what is called an evolutionary prototype. So for every iteration, you will obviously tune things to satisfy the needs of the stakeholders, and also you will also put in enough of effort to better understand the needs. So this prototype that you develop will serve as a mechanism for identifying the software requirements. So both stakeholders and engineers like the prototyping paradigm. For one simple reason, you will obviously get a feel of the actual system, and the developers will obviously feel that they have built something immediately, and that gives a good feel for both the users and the developers, and that is why prototyping is very popular among all stakeholders. So every model obviously will have its own pros and cons. Like that, the prototyping also has certain issues. So stakeholders see what appears to be a working version of the software, and they do not probably put into their minds that the prototype is only held together in a haphazard fashion. And obviously, we are not considering the quality or the long-term maintainability here. Also, the software engineer also would like to showcase something to the stakeholder to make him happy, so he makes some kind of compromises as well during implementation. He might be using an inappropriate OS or any kind of a programming language that is easily available and known to him, but the algorithm might be inefficient, and this is a major issue with the prototyping model in the long run. So we move on to the next evolutionary process model called the spiral model. The spiral model is an evolutionary process model that basically couples the iterative nature of prototyping with the systematic aspects of waterfall model. So spiral model equal to prototyping plus waterfall. So this spiral model basically facilitates rapid development of more complete versions of the software. The spiral model gains importance because it is a risk-driven process model generator, and it has two key features. One is the cyclic approach it adopts for incrementally growing the system, and as it incrementally grows the system, it decreases the degree of risk. And the second key feature of the spiral model is it has a set of anchor point milestones that basically ensures stakeholder commitment to mutually satisfactory solutions. These two key distinguishing features of the spiral model make it more interesting. So, software is basically developed in a series of evolutionary releases, and during early iterations, the release might be a model or a prototype, and later iterations will produce more complete versions of this software. So it is important to note that in a spiral model, you divide it into a set of framework activities, and they are all defined by the software engineering team. So if you look into the spiral model diagram, the first circuit around the spiral will result in the development of a product spec. Subsequent passes will develop a prototype and more sophisticated versions of the software. It is also important here that each pass will result in adjustments to the project plan, cost, and schedule. Based on the feedback, you will also be able to adjust the cost and schedule. That feedback comes directly from the customer after delivery. So the project manager will also be able to adjust the number of iterations that would be required to complete the software. So the spiral model is a realistic approach to the software development where you could develop large scale systems and software. So the spiral model is also a model which could probably reduce the risks, so otherwise called a risk reduction mechanism. So spiral model still maintains the systematic aspects of the classical life cycle model, but uses it in an iterative framework so that you will be able to mimic the real world more realistically. So the spiral model will consider all kinds of technical risks in all stages of the project, and basically this model will only serve as a risk reduction mechanism. Then you have something called the concurrent model. The concurrent model, otherwise called concurrent engineering, basically represents iterative and concurrent elements of the process models that we have discussed till now. For example, it is represented by means of states called the awaiting changes, development, awaiting changes under development, and so on. So this model is useful whenever you could probably define a series of events that will trigger transitions from one state to another. That is why there is a trigger, the requirements analysis action from the done state is gone into the awaiting changes state, and so on. So concurrent process models can be applied to any kind of software, and this would provide an accurate picture of the current state of the project. Events generated at one point trigger transitions among states associated with each activity. So in summary, you could say, evolutionary process models are iterative, incremental, and so on. So they are basically talking of prototyping and the spiral model, and these models can be adopted to apply across all software engineering activities, and the concurrent process model will allow a team to represent iterative and concurrent elements of any process model. Now we move on into a very special model called the unified process model. The unified process model basically uses the best features and characteristics of the traditional process models, but also implements the best principles of agile software development. So this model basically recognizes the importance of customer communication and streamlined methods for describing the customer's view of the system by making use of the use case diagram. This model basically looks at a process flow that is iterative and incremental, and it also provides an evolutionary feel to modern software development. This picture basically depicts the phases of the unified process model, and absolutely there is no change to the generic process framework. It has communication, planning, modeling, construction, and deployment. So all these five phases of the generic process framework can be mapped to different names. The first one is called the inception phase. The inception means starting or beginning, which starts with customer communication and planning. So you will basically collaborate with all stakeholders, identify the business requirements, have a rough architecture for the system, and you also do a planning to have iterative incremental nature for the project. When you want to look at the fundamental business requirements, that can be done by using what are called use case diagrams. Then you outline the major subsystems, the functions and features of the system, and you probably go for refinement and then identify resources, risks, schedule, and the phases of the project. And that comes into what is called the planning phase. Soon after planning, we have something called elaboration. Elaboration combines communication and modeling. So you expand the preliminary use cases, then you also look at architectural baselines, and these architectural baselines will demonstrate the viability of the architecture. Then you carefully review the plan, and at the end of the elaboration phase, I will make sure that the scope, the risks, and the delivery dates are quite reasonable. Most of the modifications to the plan are done at the end of the elaboration phase. The next phase is called the construction phase. The construction phase basically maps to the construction activity of the generic process framework. The construction phase basically involves writing the source code, going for the first increment, second, and so on. The construction phase also looks into what is called the unit testing, the integration testing, after product or component assembly, and then you derive use cases to probably write down a set of acceptance test suites that will be basically executed prior to the initiation of the next unified process modeling phase. Then you have something called the transition phase. The transition phase basically looks at the later stages of the generic construction activity and the first part of the deployment. Deployment basically involves delivery and feedback. This is where you perform what is called a beta testing. A beta testing is basically performed in the customer's premises in the absence of the developer in an uncontrolled environment. All reports, feedbacks are all logged in and then communicated back to the developer. In addition, during the transition phase, it is important that you make sure you prepare user manuals, troubleshooting guides, installation procedures, and so on. At the end of this transition phase, I will get a software increment that will become a usable software release. Then we move on into the last one called the production phase. The production phase basically maps to the deployment activity of the generic process framework. During the production phase, I will probably monitor the use of the software. I will provide necessary infrastructure for the operating environment. In addition to this, I will also look at defect reports and requests for changes are submitted and evaluated. So if you look at the unified process model, which gives you a quick summary, some notes on this. So this software engineering workflow is distributed across all phases. So you have workflow, which is analogous to a task set. The team will adapt to the process to meet the needs. So in summary, we could obviously say that a unified process model is a use case driven, architecture centric, iterative, and incremental process model that is basically designed as a framework for the UML methods and tools. More importantly, the unified process model is a best suited model because it is able to mimic what we call it as the agile methodology or the agile approach to software development. So this gives you an overall understanding of the process models, namely, the prescriptive process models, the evolutionary process models, and the unified process model. So thank you for your patient listening and hope to meet you with more lectures soon. Thank you.